right, this video is on 3.2b, complex numbers, day 2. So today we're going to solve quadratic equations with complex solutions and simplify expressions that involve complex numbers. So the first example here includes two factors that have imaginary numbers. So they're complex numbers. They got the real and the imaginary part. And I want to multiply these out. So we're going to use the FOIL to do that. So FOIL is first. So you do the 3 times the 5. 3 times 5 is 15. Then you do outside. So 3 times 2i, that's going to be 6i. And inside, 4 times 5 is 20i. And then 4i plus or times 2i is going to be 8i squared. And then we'll simplify it a little bit more. First, you can combine like terms here. And then remember that I squared is equal to -1. So you'll replace this I squared with -1. So you'll really have plus 8 times -1 here. 15, this will be 26i together. And then 8 plus -1 is actually just -8. So then I can combine the real numbers. 15 plus -8 is 7. So we're going to have 7 plus 26i will be my final answer. So I combine like terms. I change my I squared to -1, and then I combine like terms again with the real part. And I want to write it in standard form, which is a plus bi. So the real part comes first, and then the imaginary part. So let's do another one. This one, b, I'm going to use the box method. So you can FOIL again. Or the box works since it's 2 by 2. Then you would do 2 and then positive 3i and then -6 and -2i. And then you multiply corresponding spots. So 2 times -6 is -12. -6 times 3i is -18i. 2 times -2i is -4i. And then we have -6i squared. You're going to see that the like terms are in the diagonal, so you can add those together, and they're both negative, so you'll add and you'll end up with a -22i. And then here in this spot, you're going to have -6. Replacing the I squared with -1 is really going to equal +6. So then this diagonal is going to be a -12 plus a +6, and that diagonal will equal -6. Putting those together with the real part first will be -6 minus 22i. So you can either FOIL or you can use the box to help organize your work. But either way, you want to multiply each term and kind of distribute twice in those terms. So I'm just going to FOIL this one. 1 times 1 is 1. 1 times -2i is -2i. 2i times 1 is +2i. And 2i times -2i is -4i squared. Notice that when I combine like terms here, -2i plus 2i is 0. So those reduce to 0. And then I'm going to have 1 minus 4 times I squared. So 1 minus 4 times -1, which is really 1 plus 4, which equals 5. And if we look back at C, you can notice that these are almost the same thing, except for that they have, one's a positive imaginary part and one has a negative imaginary part. And then the imaginary part ends up canceling or simplifying to 0. And those actually have a special name. They're called complex conjugates. So when we use those to divide. So when you're writing the quotient in standard form, so remember, standard form is the a plus bi. If I want to write a quotient, you have to multiply by the complex conjugate. A complex conjugate is if you have the term a plus bi, the conjugate is a minus bi. So the real part stays the same. It's the same thing except for the imaginary part. One is positive and one is negative. So if I want to simplify this one, I'm going to multiply by the complex conjugate of the denominator, because I want the denominator to be a whole number. So it's 1 plus I, so it's going to be 1 minus I. If I do that on the bottom, I do that on the top as well. because then really I'm just multiplying by 1, as long as you do the same thing to the top and the bottom. So FOIL the top first. 2 times 1 is 2. 2 times negative I is negative 2I. Negative 7I times 1 is negative 7I. And negative 7I times negative I is positive 7I squared. Multiply the bottom, FOIL that out. You're going to get 1 times 1 is 1. 1 times negative I is negative 1I. I times 1 is positive I. And I times negative I is negative I squared. Combine your like terms and replace your I squareds with negative 1. So combining the like terms on top, I'm going to have 2 minus 9I. Then I'm going to have plus 7 times negative 1. So replacing this I squared with the negative 1. On the bottom, negative I plus I is 0. And then I'm going to have 1 minus negative 1. Replacing this I squared with negative 1. So then I can simplify that one more time. On the top, you're going to have 2, and then this will be minus 7. So 2 minus 7 is going to equal negative 5 minus 9I. Oops, maybe I shouldn't make that 9 look like a Q. Minus 9I over, then 1 minus negative 1 is the same thing as 1 plus 1, so that'll be over 2. And so this is my answer. If I want it in standard form, you're going to write the real part first. So really it's negative 5 halves minus 9 halves I. So it looks like that. So then you really have your A plus your BI piece. So dividing that into 2 pieces. The 2, just like you divide a regular statement, you need to divide everything by 2. Okay, we got a couple more that we'll do like that. So you're going to multiply by the complex conjugate of the denominator. So if it's A plus BI, then you multiply by A minus BI. The real part always stays the same. So this will say negative 2, but since it's plus I, it'll change to minus I. And then you'll multiply by negative 2 minus I on the top. Distributing or foiling on the top, I'm going to get negative 6. 3 times negative I is negative 3I. I times negative 2 is negative 2I. I times negative I is negative I squared. Okay, foiling on the bottom, negative 2 times negative 2 is 4. Negative 2 times negative I is positive 2I. I times negative 2 is negative 2I. And I times negative I is negative I squared. Combining like terms and simplifying, or combining like terms and then replacing I squared with negative 1. You're going to get here, it'll be negative 6 minus 5I minus, and then replace that I squared with negative 1 over. Then we have 2 plus negative 2, or positive 2I minus 2I, that's 0. So you're going to have 4 minus the negative 1. Simplifying one more time, I'm going to have negative 6, it's going to be plus 1, it's going to be negative 5 minus 5I, and then on the bottom, 4 minus negative 1 will be 5. So we could reduce this to 5 over 5 minus 5 over 5I. So really it's just negative 1 minus I, or minus 1I. So that's what it reduces to there. Okay, one more. This one involves a square root, but essentially it's doing the same thing. We have 2 minus I square roots of 5 on the bottom, so our complex conjugate is going to be 2 plus I square roots of 5. Do the same thing on the top, 2 plus I square roots of 5. FOIL, 3 times 2 is 6. 3 times I square roots of 5 is just going to be 3I square roots of 5. Since 3 is a number on the outside of a square root, it goes together with the outside I, not the 5. Same with the 2 times I square roots of 5, that's going to be 2I square roots of 5. And then I squared of 5 times I squared of 5. We're going to multiply the i's together and get I squared. And the square root of 5 times the square root of 5 will be the square root of 25. You multiply the two 5's together because they're both inside the square root, so those two can be multiplied together. Foiling on the bottom, 2 times 2 is 4. 2 times I square roots of 5 is 2I square roots of 5. Negative I square roots of 5 times 2 is minus 2I square roots of 5. And negative I square roots of 5 times positive I square roots of 5 is negative I squared square roots. 5 times 5 is 25. This one requires a little bit more simplifying, so we want to combine our like terms, replace our I squareds with negative 1, but then we also have a square root of 25. And remember, the square root of 25 equals 5. So we're going to replace the I squared with a negative 1 and the square root of 25 with a 5. And we're going to do the same thing down here. So this is going to look like this. We're going to have 6 plus 3I square roots of 5 and 2I square roots of 5. They have the same thing attached to them, so those are like terms. So that's 5I square roots of 5. You just add the coefficients, just like you add 2x and 3x is 5x. And then you're going to have plus negative 1 times 5 will be plus negative 5 there. All over 4, 2I square roots of 5 and negative 2I square roots of 5 equals 0. Then you have minus, and these two will give you another negative 5. So combining like terms one more time, I'm going to have 6 plus negative 5 is 1, plus 5 square roots of 5I square roots of 5, and then that'll be over 4 minus negative 5. It's going to be over 9. And then to write it in standard form, it's going to be 1/9 plus 5I square roots of 5 over 9. So we can identify the real and imaginary part. Essentially, these two are the same thing. But this one makes it clear that 1/9 is the real, and then this is the imaginary over here. Okay, so just some review. The square root of any negative number is always imaginary because the square root of negative 1 is I. I squared equals negative 1 then. This is a complex number. The complex conjugate is if you have A plus BI, then the conjugate is A minus BI. If you have A minus BI, then the conjugate is A plus BI. Remember to add or subtract any of your like terms. Okay, thanks for watching.